There are many techniques used for identification of an unknown organic compound. The three we have talked about in detail this semester are mass spectrometry, infrared spectroscopy, and nuclear magnetic resonance spectroscopy. Mass spectrometry uses a beam of electrons to determine the mass-to-charge ratio of a sample. The electrons cause compounds to break into fragments of different masses. The fragmentation pattern determines identity of a compound.
NMR spectroscopy uses radio waves that determine physical and chemical properties of atoms. In this experiment, infrared spectroscopy is used and discussed in further detail. The three can be combined to form a very accurate identification of an unknown organic compound. In this experiment, the infrared spectrum of two unknown liquids and an unknown solid was determined using IR spectroscopy. A plot of transmittance versus wave number was generated, and the peaks were measured to determine which functional groups were present in each unknown. The unknowns were identified from a list of possible unknowns.
Infrared spectroscopy is used to determine the functional groups in a compound. The compound is measured by its percent transmittance and its wave number, which is the inverse of wavelength. The signals occur due to stretching, scissoring, and bending of the bonds in a compound.
An infrared spectrometer was used in this experiment. It was linked to a computer and the information collected was plotted. The first liquid unknown was ran in a spectrometer using a sodium chloride salt plate. The unknown was dropped onto the plate and the other plate was secured on top. It was placed in the IR spectrometer and the sample was tested. The other liquid was dropped directly onto a platform of the spectrometer. A sample was then covered with a crystal and the sample was tested on the machine. The crystal did not have to come into contact with the liquid, but did need to be directly above it. The solid unknown was ran the same way, except the crystal had to come in contact with the solid in order to get an accurate measurement.
Here is a chart with the corresponding wave numbers for each of the common bonds.
First 10 compounds in this list are the possible unknowns for this experiment, along with their formulas and molar masses. The last 6 compounds are the possible unknown solids. This is the plot generated from unknown liquid 6. Peaks are shown in the functional group region at 2800 to 3100 inverse centimeters, and also around 1700. There is also a peak at 1600 inverse centimeters and a lot of peaks in the fingerprint region, which is below 1500 inverse centimeters.
The peaks around 2800 inverse centimeters represent the sp3 hybridized CH bonds. The peaks at about 3000 inverse centimeters represent the aromatic CH bonds. The 1700 centimeter peak represents the CO double bond, and the 1600 peak indicates a benzene ring. The fingerprint region represents the CO single bond and also more sp3 CH bonds. From this information, it is concluded that unknown liquid 6 is ethyl benzoate.
Unknown liquid 10 displayed 2 peaks in the functional group region. One peak was found at 1700 inverse centimeters, which indicated a ketone. The other peak was found around 2900 inverse centimeters. This represented an sp3 hybridized CH bond. The fingerprint region showed a few small peaks. There was an absence of a peak at 1380 inverse centimeters in the fingerprint region, which showed there were no methyl groups. This indicated the structure was a cyclic alkane.
From these peaks, it is concluded that unknown liquid 10 is cyclohexanone.
Unknown S4 displayed only one peak in the functional group region. This peak was at 2,980 inverse centimeters. This peak was in the range of the CH bonds. Since this was the only peak, it indicated that the unknown did not have any oxygen or nitrogen in it. This ruled out ketones, alcohols, amines, and amides. By process of elimination, the unknown most closely matched anthracene.
Anthracene has a structure that contains cyclic alkenes, but a peak was present at 2,980 inverse centimeters, which indicates an alkane. This shows that there was some error in the experiment. The unknown is still most likely anthracene, but the peak was shifted to a smaller wave number because an outside factor interfered with the sample. The outside factor most likely slowed down the frequency, therefore making the wave number less than expected. This outside factor was most likely due to some type of background noise.
The peaks do not perfectly match any of the unknowns, but the most likely choice was anthracene. Unknown liquid 6 was ethyl benzoate. The formula is C9H10O2 and the molar mass is 150.18 grams per mole. Unknown liquid 10 was cyclohexanone with the formula of C6H10O and a molar mass of 98.15 grams per mole. Unknown solid 4 was anthracene with the formula of C14H10 and a molar mass of 178.23 grams per mole. In conclusion, the identification of an unknown using infrared spectroscopy was successful in 2 out of the 3 unknowns. The 2 liquid samples were narrowed down to a single unknown, but the spectrum for the solid did not match any of the given unknowns. The unknown solid chosen represented the closest matched compound.
Overall, this experiment allowed for use of new lab equipment and a new identification method. This method, along with mass spectrometry and NMR spectroscopy, can be used to accurately identify most all unknown organic compounds with confident results.